The atomic orbitals are regions of probability where we're most likely to find the electrons. They're regions of space around the nucleus where the electrons most likely to be located. And these were discovered by this man right here, Erwin Schrödinger. And he developed a mathematical equation called a wave function, and that we use the quantum numbers, which we learned about, and put them into the wave equation, we'll actually see what these regions of probability look like. So let's start with the first one here. And the first region of probability is the s orbital. Okay, we know this has the quantum number of L is equal to 0. Right, so we've seen that before. And the s orbital is going to look like a sphere. And so we have the s orbital is going to look like a sphere, and it's kind of like a cloud where the nucleus is right there in the center, and that's what that orbital looks like. The next one is the p orbital. Here we go, the p orbital, and this is going to look like a peanut shape. Some would say it's a dumbbell shape. And the p orbital is going to look just like this. Again, it's a region of probability. It's a cloud. You got to imagine this thing in 3 dimensions, where the nucleus is right here in the center. And so we have this peanut shape. The next one is the d orbital. The d orbital, and this is going to be a double peanut, or some would say double dumbbell shape, and it's going to kind of look like this, where we have 2 of those p orbitals. Again, imagine these in 3 dimensions, regions of probability, and right in the center is where the nucleus would be located. And the last one we'll talk about here is the f orbital, and this one looks like a flower, kind of. I'm taking some liberties in saying that, but it's going to kind of look something like this crazy looking shape here. Again, 3 dimensions, nucleus right there at the center, and these are the shapes of our 4 different orbitals. Now, if you think back to the video on quantum numbers, for every energy level, we're going to have these sublevels and have these orbitals, and that each energy level, as we go up in energy levels, we're going to add 1 sublevel each time. So let's just revisit this really quickly. So if n is 1, we will have possible sublevels of s, and only s. Remember that L is equal to 0 up to n minus 1. Alright, so we only have the possibility of 0, and s stands for an L value of 0. And so the number of orbitals would be 1, and that's it, just 1 orbital in the first energy level. Let's move up to the second energy level here. So as we go up to the second energy level, we're going to have sublevels, L stands for sublevel, of s and p. And the s sublevel is going to have only 1 orbital, whereas the p sublevel will have 3 orbitals, and so we have a total here of 4 different orbitals. Going up to the third energy level, we're going to have s, p, and d. Remember, these are the sublevels, and the s will still just have 1 orbital, the p will have 3, and the d will have 5, so we have 9 different orbitals at this point. And let's just add 1 more energy level here. We'll go up to the 4th energy level, where we have s, p, d, and now f. We're adding 1 sublevel each time here. The s still has 1 orbital, p has 3, d has 5, and f has 7. You can see that we're adding 2 orbitals each time, so for a total of 16 different orbitals. And let me just add 1 column to the right here, because now that we know how many orbitals there are, and we know that in each orbital we can only hold 2 electrons, let's actually just write down how many electrons each of these energy levels could hold. So in the first energy level we can have 2 electrons. In the second energy level we're going to have 8 electrons. In the third energy level we'll have 18 electrons. And then in the Fourth energy level here will have 32 electrons.